In the government's latest response,
you must stay at home.
Master of the house, doling out the charm.
It's very important that everyone
know that you are not alone.
So this is the first of the series on naming organic compounds. This is our general set of rules, which all other namings will be based on. I would suggest you start here. It's not entirely necessary. You can look at each individual set of rules individually, but I think this is a good starting point. So when we name our organic it sometimes seems like organic chemistry is a lot of just learning how to name stuff, and in the very early parts it is. But that's important, right? Because when we talk about organic chemistry, we're talking about variations which lead to billions upon billions of compounds, or billions and billions of compounds. That was for me. So we want to be careful, right? We want to make sure we have a really systematic name, series of names. Now, some of these chemicals that we'll look at over the next series have multiple names, and that makes sense, right? Like, because they were discovered or utilized before we came up with it's called the IUPAC, International Union of Applied Chemists, except in French, naming system. Now, on top of that, though, there's also the thing of once something has a name, it's established, like the Brontosaurus, right? Like, once it's called a Brontosaurus, everyone knows it as a Brontosaurus. Ethylene, everyone thinks of as ethylene, but ethene is the proper name for it. Acetone, and a whole bunch of stuff. So we're looking at the systematic naming. And this is a general set of rules that will hopefully make sense. And we'll apply these to specific situations in other videos in this series. So our learning goal here is to be able to name simple organic compounds from their structural formula. Now, again, I would say this is an intro, and you probably get a bit better at that at the next one. But we're going to look at how the name is broken down. Here's your vocabulary. Here's a good point to pause the video, hit subscribe, why not, and write this information down, just so you've got these new terms, if they are new terms to you, to refer back to. This particular diagram right here, all the different families or functional groups that we will look at, golden. I would make sure you've got that down as well. So, the components of an organic compound. We have the R group, right? Let's get our highlighter ready here. So we have the R groups, okay? This is your hydrogen backbone, okay? So here we have an R group of only 2, okay? Now, this being ethanoic acid, we'd say the R group, or the chain, is going to be 2 carbons long, but we'll actually refer to just this section as the R group, but the chain is too long, okay? So it's the hydrocarbon backbone. So it only has hydrogens and carbons. We then have functional groups. That would be this section here. It's what makes it special. It's the defining section of that thing, of that compound. Now, lots of compounds will have multiple functional groups. This is why we have a order of priority. Now, this is not a 100% set order. There's actually a little bit of, what do you call it? There's a little bit of variability in this from different places you look, but this is the most standard version. The only thing that I would say gets a little bit iffy is that the haloalkanes, because they are haloalkanes, you just basically put a halogen name at the front. That could actually be up here if you want it above it, but whatever, right? So the first one is alkane, or alkane, alkene, alkyne. But then if you find that there's an OH group, we name it as an alkanol or an alcohol, not as an alkane. So we see as we move down esters, if something's got an alcohol and an ester in it, we're going to call it an ester, and the alcohol will be a side chain. We'll get to that in a minute. But here's the priority. The highest priority of the things we deal with is the carboxylic acid. So let's move forward. Prefixes, infixes, and suffixes. So these are the 3 parts here, and we're going to talk about propanal right here. That's this compound right here. We're going to use that as our guide. First thing I will say is that we use two different types of naming. We use, for talking about chain size, we use meth, eth, probe, boot. It's but I like boot. Pent, hex, hept, oct, non, dec. We're not going to get up to 10. We can go beyond that, but these are what we would use for the chains. But if we have two of something, we'll use the di, tri, tetra, so forth. Okay, so prefixes, infixes, suffixes. What makes up a name? Let's have a look. So prefixes are what give us the length of the carbon chain. So you see, well, I'm going to highlight here. Prop, in this case, means 3. Okay, and the carbon chain here is 3. So that's our prefix. That's the bit at the beginning. Then we have the infix. It's going to about how many double bonds there are, or triple bonds, or whatever. So infix denote the type of carbon bonds. In this case, En for double bonds, ein for triple, An for single. There is a double bond. That's the highest priority. If there's a triple bond and a double bond, the highest priority would be the triple bond. So this is prop-ene. And then we look at the functional group. Now we have the double bond here is a functional group, but there's one here called an aldehyde. If it's down here. So that looks like our carbon here. So that makes it an al. The suffix is an al. So propene-al. So to name it though, we then go prop to ene to show us. Yeah, okay. So we number it, just as a little note here, we number it so it gets the lowest possible number at the functional groups. In this case, we would number it from this carbon here. So 1, 2, 3. Okay, so prop to ene, the double bond happens at the second carbon, 1 al. And we'll get to how that's set up in a minute. But that's prop to ene 1 al, or propanal. But that's the proper name down the bottom there. All right, so what are the naming rules? And we're going to use this one over the side here as our example. Okay, so this is a little bit of where my animating has gone a bit sideways. So the first thing we do is identify the longest parent chain using the following rules. And it's the order of precedence, okay? So it contains the parent functional group. We have a look here, and we have a functional group OH, which is higher than the fact that it's an ane, because there's only single bonds. Okay, so it's an OH, which is an alcohol. Contains the maximum number of multiple bonds. There are no multiple bonds. That's good. And this gives the prefix and maximum number of carbons. So we can go 1, 2, 3, 4, or 1, 2, 3, 4. It doesn't actually matter. So it's 4. So that's bute from the previous list. Okay. So we have a butane. All right, nice. Identify the highest order functional group. That's going to be this alcohol right here. That gives us the suffix. So we have an alkanol, which is ol. Then we have the number of parent chain in either direction. In functional group, blah, blah, blah. Oh, so number it. Sorry, yes. So we would number it from here. So it'd be 1, 2, 3, 4. Because we want to give our functional group the lowest possible number. See, there's numbered there. 1, 2, 3, 4. And we then identify any single triple bonds, triple double bonds. There are none of those. Then, so that's all identified on there. So single bonds, the infix is an. That's what that's saying. Side chains are giving the prefix, or suffix actually. Well, it's a prefix at the front, but they end with YL. And there's one there. Now, there's only one carbon on that, so that would make it methyl. Okay, methyl. We add those, so if there was 2 of them, we'd call it dimethyl, trimethyl for 3, so forth. And then we place any positional numbers. So this will be a ol 1, and this will be methyl at the 3 carbon. So that's off this carbon here that it joins. So it's a 3 methyl. Now, however is it? Numbers are separated by commas, and numbers and letters are separated by hyphens. And that's because these are single words. So here we have 3 methyl, butane, and 1 ol. And we put that all together. We have 3 methyl, butane, 1 ol. It's kind of fun, right? Now, that was a lot there. It gets much simpler the more you practice it. That's all. A lot of it will become fairly instinctual, but that's the systematic way to do it. So, if you have any questions, put them in the comments below, and I'll get back to you as quick as I can. Thank you for watching. Don't forget to subscribe so you can keep up with what we're doing. And this is just an intro. If you want to talk about, say, specific ones, they're all in a, search for those as well under my channel, and they'll be there as well. And all follow this particular format. And they'll have examples on how to do each of those. Thanks for watching, and see you next time. Bye now.